I'm checking that you can write the expression as a simplified exponent, okay? Rational exponent means positive exponents only. So they just kind of gave you an example of some things you need to know in regards to using the rule, and they've given an example per rule in each box. So if you just kind of, I'm going to just kind of break down how the flow of the packet goes. So if you kind of look at the rule, like this one is the product rule, and they wrote it for you here, a to the m times a to the n. Here we're just, they have the same base, we're adding the exponent. They've given you the keywords to that rule as well. Now, if there is a coefficient, you're going to multiply those coefficients, meaning if there's a number in front of the letter, you multiply those. So on here, since they have the same base of 5, that's saying 5 to the power of 2 plus 6. So if you simplify it, this is 5 to the 8th power. As long as you get to the simplified exponent, we're good. You can still put this in the calculator and actually get a numerical answer for that. So does everyone know how to use the calculator? You can do an exponent greater than 2. Okay, because if you need to do that, put the number into the calculator and simplify that. So like, I don't have my calculator up. Let me do that. So if you put 5 to the 8th power, I need to put mine. There it is. So we're doing, let me get out of this. 5, and then the caret above the division power lets you do the exponent box, and then the 8, and then you get your numeric simplified answer, okay? But as long as you get to the simplified exponent, I'm gonna give you full credit. So if you do not see an exponent, like on this next one, the next exponent is missing right here. It's like an invisible 1 there, so you can add them up. So on a problem like number 7 here, you have coefficients. So you're doing 7 times 6. Then you go to the variable. Remember, if you don't see an exponent as an invisible 1. So that's y to the 5th power plus 1, plus that 1 exponent. So yes, that gets simplified to, when you multiply that together, oops, sorry, 42 here, right? Y to the 6th power. Okay. So I'm trying to give you the keywords, like an example to each rule, and the keywords to that rule. The quotient rule here is like dividing. So quotient is when you're dividing two numbers, same base, subtract the exponents. So if I don't see the exponent, we've got to remember that's an invisible 1 there. So this is saying y to the 6 minus 1. So y to the 5th. Okay. If they're numbers, then you reduce it like you reduce a fraction. So on here, let me just fix this. This 10 over 15 can be reduced. I'm just going to reduce that fraction. That is going to be 2 over 5. Then what I'm going to do is I'm going to go to the exponents, right? We have a to the 7th, a to the 5th. That's like saying 7 minus 5. You subtract those. And I go to the next variable, which is b, 9 minus 9. Right? So when I simplify everything, we have 2/5 a to the 2nd power, b to the 0 power. We have to remember what that happens there. Whenever you have b to the 0 power, do you know what that becomes? Just a 1. Okay? Huh? Oh, sorry, 2/3. Where's my eraser? You can write this also, because this is like saying over 1. This can also be written as 2a squared over 3. These are the same answer. If I do 2/3 a squared, this is the same answer as putting that on the top of the fraction. All right, so even on this 0 power on this next page, okay, since they're putting this whole expression to the power of 0, it's still going to just be 1. I don't look like a 1. Okay. The difference between is this whole thing was inside the parentheses. This does not have parentheses. Okay. So that means I'm putting x to the 0. That becomes 1. So this is like saying 8 times 1, then plus 5. So you do have to simplify that one. There's a difference between when it's grouped versus not grouped. Okay, if it's not grouped, you have to do each individual term. Okay. Yes, 13. All right, so since here for your negative exponents, any to a negative exponent, okay, it says right here, rewrite the power with a positive exponent. So we have to, this is like saying b to the second minus 5. This is to the negative 3, but we can't leave that like that, so it's 1 over b to the third. So I could rewrite this as 1 over 2 to the third power. This would be 1 over, don't forget your negative 3 to the third power. These turn into numbers. So there is I want the final numeric answer. Use your calculator to help, okay?
Negative 4 over 27.
Yeah. And then on your last page, a power of a power. So that power needs to be outside the parentheses. Anytime that's usually a clue. If I see a parentheses and I had an exponent outside that parentheses, you need to multiply the exponents. So follow your exponent rules, like a negative times a negative, so going to turn into a positive 12. And if I have parentheses and an exponent outside the parentheses, it says right here, find the power of each factor in the parentheses and multiply. So we have to put the power to each factor, meaning each number and variable. So like this would be 4 to the third power. Then my x, oops, sorry. It's already to the third power, but then I'm raising it to another third power. So that's when you multiply it, because I'm distributing this 3 to each term. Then I go to my y. My y, oops, sorry, x to the third times 3. My y is an invisible 1. So that would be, actually 1 times 3 would just be 3. And then my z, also a visible 1.
Don't you need a cube?
I did 4 to the cube. It's in red. So you do need to simplify that. That's going to come out to be a number. 4 to the third power, 64. Then my x goes to the power of 9. Y to the third power, z to the third power. And that is your final answer. The same thing applies if you have a fraction. So notice that there's parentheses here. The M, the exponent, is outside the parentheses, so they distribute to both. This right here, you're going to raise, the power is raised both to the numerator and denominator. So this is like saying 3 squared over 5 squared. You have to raise it to the top and to the bottom. Okay? All right, so make sure your name's on this packet. When you're done, you can put it in the tray. Or you could keep it because there is going to be an Alex that correlates with it. Kind of where I'm going to give you 1 or 2 problems from each box, from each power rule. Alex won't be due till tomorrow. Mm-hmm. Yep. Mm-hmm. Like, don't you have... Guys, when you get done with the packet, your Alex work is going to go on the back of the packet. Like, flip to the last page.
Yeah.
You see how you space? Yeah. Your Alex work is going to go on the back.
If I can do like some of the problems.
Yeah, you can do them mentally, but some you might have to do each term. Okay?